voltage. Throttle position sensor. We can just crank that and we can see that it goes up like that. And you can also notice that ignition advance is 3 degrees at starting, and then as soon as it gets started, as soon as it's running, it goes to 10 degrees advance and then gradually decreases as it gets to full throttle. Okay, engine configuration: 1 liter piston engine, 4-stroke, 2 cylinders, naturally aspirated. It doesn't crank. It cranks at about 500, I think it was. Odd fire engine, which gives us more flexibility. Cylinder 1 fires at 0. Cylinder 2 fires at 270 degrees after the first one. Okay, so that's the first stuff, the first primary details, and then we get to the trigger. And here we go. Missing tooth, no home. So that means it's not using a single tab on the cam to reference the home position. So trigger signal location is on the cam, which is this cam drive gear. Number of teeth, 48, as I mentioned, 48 teeth around here. And number of missing teeth is 2. Oh, what are you doing? This thing has got some weird glitches. Okay. Tooth count till start, that just means how many times do you want it to, how far do you want it to spin before you apply the starting mixture corrections. And here is the critical number. TDC angle is 340 degrees. Now that, on all the documentation, it said that that was the crank angle, but that's only if the crank is used to measure the rotation and position of the engine with a single tab on the cam. That's actually how the Husqvarna works, because around the end of here, where the crank rotor is, it's got many, many teeth. I don't know exactly how many, like 60 or something like that, with a double, and on the camshaft it has just one single tab. But in this case, when you're using the cam, as defined here, you don't use crank rotation from the trigger to TDC1. Yeah, you use the angle of the cam. So that's actually half the number. So I had to measure the angle of motion, the angle between here, and that is 340 degrees. And then the computer knows when to fire the plugs and when to fire the injectors. The sensor type is reluctor, so that's what this is right here. This sensor here is the one that reads it. That's just a little magnet, and it detects, it can feel a difference in the magnetic field when it passes across a piece of ferrous metal. It feeds the computer with a sine wave, and the computer can detect that sine wave and then do a bunch of calculations based on the number of teeth that go past it. Reluctor is the sensor, falling edge, blah, 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 all those various settings. And with that, the ECU is able to do the basics for getting the engine to run. Now, with all of this, we have, that's the starter button, we have the fan, the radiator fan connection, simple fuse on that one. That's the fan relay. We have the fuel pump relay. We have the fuse block. I've just got this little Husqvarna one in place for now. I'll go back to the stock OEM Ducati unit. We have the ECU relay. That's the injector relay, and that is the ignition relay. And each one of those goes through the fuse box, of course. We've got battery 12 volt, which is always on. And here is a switched 12 volt, so functions that we only want to work after you turn the key on. We have battery ground, which is separate from chassis ground, of course. We have signal ground because all of the sensors use 5 volts. The battery and the chassis ground are 12. So signal ground is separate from chassis ground and battery ground. And here is the sensor 5 volt bus. Let's see, these are the sensors. This is the manifold air pressure sensor. So if we just blow in this and you look at the yellow, that's working. This, oh, there's the coolant temperature sensor. So if I hold that for a little bit, you'll see the red starting to increase, 56, 57, 58. So that's working nicely. And we have the air temperature sensor, which is the ambient, or sorry, the inlet temperature, which is the blue. And you can see that rising up quickly because the sensor has a lot less inertia. And there it's going down again after I let it go. And ECU temp doesn't work. That's not important. And we also have an oil pressure sensor. But that's actually that's this wire right here. That's why it's not reading. All right. Yes, I did have to crimp and install each one of these wires. This is the wiring diagram, which has been getting a lot of use. These are all the different functions. That's the fuse block, throttle position sensor, temperature sensor, map sensor, blah, blah, blah. I could go on forever about this. And that's the other pin. The smaller pin is 26. Crank trigger input we didn't use. Cam is what we used. And it also has CAN bus outputs available. Air temperature sensor, coolant temperature sensor, and on it goes. So we had a few problems, a few obstacles had to be overcome. First among them was there were too many to note. But in the end, I ditched the Ducati coils and went with these Haltech units because I knew they would be compatible, and they work great. Very big fat spark coming out of those. I tried the Ducati coils, and they had a lot of problems. The one that came with the bike had a giant crack in it, so it didn't have the right resistance measurement. I bought another pair of supposedly new old stock, and they also didn't have the right resistance values, so that's why I went with the Haltech ones. What else? We've got a bunch of different connectors that I need to install now that it's running, so I literally have to build a wiring harness for this. So these are the wires. For example, the TPS, that's the throttle right there. All of the injectors, that's the positive from the relay, because the computer outputs negative signals, so it grounds out the wire. It doesn't provide a positive, it literally provides a negative. It grounds out. So these are all the different injectors. 1, 2, 3, 4, ground, and then the positive for the power. Grounds for the coils. Yeah, it actually all does make sense, but it took a while to get it all figured out. So, for example, this is the check engine light. So this is going to go up to the dash only has an engine oil pressure warning light, so I'm not sure where we'll put this. We might not use it at all. The wiring for the coolant temperature, positive, ground, and signal, I've calibrated it, so 1.5 volts shows exactly 100 degrees. I just need to wire that in, but it's not working, so I have to talk to Haltech to see why it is that when I calibrate it, it works perfectly. I just literally connected a 1.5 volt battery to it across the signal wire and ground, and the needle moved perfectly up to 100. I've got the calibration table in here for the coolant temperature, but it's not working properly. I've got the tachometer wired in, actually right here, using the stock harness. It is supposed to, well, according to the documentation, it's supposed to show 100 RPM per 33 Hertz. But with my fancy diagnostic tester, it's not working. I've got it putting out 100 Hertz and it doesn't work. So frequency 1000, I turn that down to 100, connect it to the wire, and nothing happens. So I need to find out about that. That's the connector for the signal generator. Okay, so that's where we're at. The engine is running. If I can, I'll post a little clip that I recorded with my phone and we'll be able to see it. It's a little loud and raucous, but it works. The story behind this is apparently it was crashed and the owner took it to a dealership and they started work on it, and then when he found out how much the repairs were going to cost, he literally just abandoned it. So it was, the dealership had it in boxes on shelves and sat in a corner of the dealership for years before anyone paid any attention to it. And the reason it was crashed is